Okay, guys, so this is part 2 for inverse trig. Okay, so the first part we were just working on evaluating, evaluating the different functions. Okay, so now we're going to add in a little extra layer of that where you have one function inside of another. Okay, so the big thing again is you're just paying attention to which function you're using and then where on the unit circle you would use that function. Okay. So this first one, I have inverse sine of pi over 4. Okay, so you always work on the inside part first and then the outside part second. Okay, so sine of pi over 4, if you're looking on your unit circle, is the y term at pi over 4. So that's root 2 over 2. Okay, now inverse sine of root 2 over 2, where does the y term come out to be root 2 over 2? That's going to be pi over 4. Okay, so the answer to this question is pi over 4. Okay, now I know you're looking at this and saying, oh, well, I could have just done this and that, and then my answer would be just pi over 4. Okay, it doesn't always work out like that. Okay, sometimes it does, but I wouldn't get in the habit of doing that all the time because sometimes it's just not that easy. Okay, so I think it's a good idea just to kind of walk yourself through it so you get the right answer every time. Like this one. Okay, now I can't do just this and then that because inverse sine does not go with 3 pi over 4. 3 pi over 4 is in quadrant 2. I need something in quadrant 1 or 4. Okay, so I can't just cross things out and make that my answer. Okay, so again, you're looking for sine of 3 pi over 4. Okay, so which is negative root 2 over 2. Okay, and then where on the first or fourth quadrant is the y term going to come out to be negative root 2 over 2. Okay, which is negative pi over 4. All right, so again, make sure you're changing those angles in quadrant 4 so that they are they fit in the right range. Okay, third question. So arc sine of 13 pi over 10. Okay, now I don't know. 13 pi over 10 obviously is not on the unit circle. All right, but that's quite all right. We can kind of figure it out where it would go, right? So if you draw this one out, right, 13 pi over 10, right, because this is pi, which is 10 pi over 10. 13 pi over 10 is going to go right about there. Okay, now at that point, right, you're going to have a negative x value and a negative y value, right? I don't know what that y value would be, but I just know that it's got to be in quadrant 3, right? What I want to do is, now the distance from the axis to this angle, right, is 3 pi over 10, right? It's the reference angle. I need something in quadrant 1 or quadrant 4 that has that same reference angle, right? Now, I don't want to use quadrant 1 because all the y values are positive in quadrant 1, okay? So that's not going to help me, okay? But if the quadrant or the values in quadrant 4, they're all negative, so that's going to help me, okay? So if I start here at 0 and I draw my reference angle of 3 pi over 10, right, that's going to give me negative 3 pi over 10, all right? So at negative 3 pi over 10, we know that it has some x value, and it's going to have a negative y value. That negative y value is going to be the same that you have at 13 pi over 10, all right? So as we work through this, all right, sine of 13 pi over 10 is going to give you some y value, okay, which is this one here. So you can say like arc sine of some y value, right? It's a ratio. Okay, where does sine have that same y value or same ratio between negative pi over 2 and pi over 2? Well, that's this angle here, because it has the same reference angle. So my answer to this is negative 3 pi over 10. Okay, so you're changing the angle that you're given to a place that you can use inverse sine, okay, and it has to have the same reference angle, all right? So again, this is going to give me a ratio, okay? So arc sine of this ratio. Where else does that occur? We already know that it occurs at 13 pi over 10, but now we also know that it occurs at negative 3 pi over 10. So that's how you're getting your answer. You're changing it to a place that you can use. Okay, and then letter D says sine of inverse sine of 3 over 4. Now, 3 over 4 is not a ratio that you have on your unit circle, okay? But that's all right. You can draw it out. If you're given something that you don't know, draw it out, okay? Now, 3 over 4 is positive, right? So that tells me that it's got to go in quadrant 1. If it was negative, I put it in quadrant 4, right? So if I draw my angle, right, and then I'm going to draw out my triangle, all right, what's going to happen is that inverse sine of 3 over 4 is going to become some angle. I don't know what that angle is, but that's not really that necessary. So this angle is right here in the corner between your terminal side and your initial side, okay? So if I know it's inverse sine, I'm going to label the triangle based off of what I'm given. So we know that this side would be 3, and then this side is going to be 4, okay? So when I do sine of that angle now, right, it's still going to give me 3 over 4. Okay? Now, if you somehow needed to use the other side, this missing side, you just would have to do Pythagorean theorem, and then that would give you the answer, which is root 7. Okay, so we didn't really need that for this one, but that's okay. All right, so cosine of inverse cosine of pi. Okay, so I think I think I typed this wrong, so I'm going to change this. So so I have cosine inverse cosine of 1. Negative 1. We'll make that negative 1. Okay, so where does cosine have a ratio of negative 1? Okay, you're looking at the top half of the unit circle. Where does the x value come out to be negative 1? Okay, so you have cosine, that would be pi, and then cosine of pi is negative 1. All right, now this one you have inverse cosine of 3 pi over 4. Okay, so cosine of 3 pi over 4 is negative root 2 over 2. Okay, and then where does that occur? Which angle has an x value of negative root 2 over 2? So we know that that is 3 pi over 4. The next one, you have arc cosine of 7 pi over 6. Okay, so what is cosine of 7 pi over 6? All right, that is negative root 3 over 2. Okay, now what's arc cosine of negative root 3 over 2? That's going to be 5 pi over 6. Okay, so again, arc cosine has to be in the top half of the unit circle. It has to go from 0 to pi. 7 pi over 6 is too big. Okay, so you have to use the angle that's in the right range, which would be 5 pi over 6. Okay, So this is kind of similar to the one we just did a couple examples ago. So 23 pi over 7, right? Where would that go? All right, so 2 pi, I know, is 14 pi over 7, right? That leaves me with, and then this is 7 pi over 7. How much more do I need to go to get 23, right? So that's going to be 9. All right, so here would be 23 pi over 7, or 9 pi over 7, right? They're coterminal with each other, okay? Now, when I'm doing inverse cosine now of some angle, right, I have to make sure that it's in the top half of the unit circle. 9 pi over 7 clearly is not, right? But what's the reference angle? As I go from the angle to the axis, that's 2 pi over 7, all right? So if I go another 2 pi over 7 here, that's going to give me the angle that has the same ratio, right? Because we know that this is negative x and negative y. Where would you get that same negative x value in quadrant 2? Okay, so if you go another 2 pi over 7, that's going to give you your answer, or 5 pi over 7. All right, so cosine of 23 pi over 7 and cosine of 5 pi over 7 have the same ratio, okay? But 5 pi over 7 is in the right range. Okay, so we have inverse tan of 7 pi over 4. So inverse tangent of 7 pi over 4 is going to be -1. And then inverse tan of -1, it's got to be between negative pi over 2 and pi over 2, is negative pi over 4. Okay, and then you got arctan of, now tangent at -4 pi over 3. Okay, now what is the coordinate there? That coordinate is going to be -1/2 and then √3 over 2. So if I do the y term divided by the x term, that's going to be -√3. Okay, now I need to figure out where in between negative pi over 4, negative pi over 2 and pi over 2, am I going to get, when I do the y term over the x term, it's going to come out to be -√3. All right. Now, if I go back up to my unit circle, all right, I need 1/2 and √3 over 2. All right, so if you look here, if I do the y term over the x term, that should give me -√3. All right, so the angle that I want is going to be negative pi over 3. So that would be the answer for this one. All right, so just a couple more. So now we're going to throw in maybe not the same function and inverse with each other. Going to mix it up a little bit. All right, so now we got -√2 over 2, our cosine of that. All right, so that's where's the x value? -√2 over 2. All right, so that is 3 pi over 4. And then sine of 3 pi over 4 is √2 over 2. Okay. Sine of 5 pi over 3, that is -√3 over 2. And then arc cosine of -√3 over 2 is going to be 5 pi over 6. Okay, so we have inverse tangent, cosine of pi, we know is -1, and then inverse tangent of -1 is negative pi over 4. Okay, arc sine of -√3 over 2. right? Where's the y value? Negative root 3 over 2. And that is going to be negative pi over 3. Okay, now if I'm doing negative pi over 3, that's 1/2 and negative root 3 over 2. Okay, now when I do cotangent, it's the x term divided by the y term, okay, which is negative 1 over root 3 or negative root 3 over 3. Okay, so I got secant of arctan sine of 3 pi over 2. Sine of 3 pi over 2 would be negative 1. Okay, arctan of negative 1 is going to be negative pi over 4. And then secant of negative pi over 4 is 1 over the x term, which is root 2 over 2. So 2 over root 2. And then you simplify 2 root 2 over 2, which is then just root 2. Okay, so you got cosine of arcsine. Tangent at 5 pi over 4 is going to be positive 1. Okay, arcsine of 1, right? Where would the y value be positive 1? We know that that is pi over 2. Cosine of pi over 2 is 0. All right, so now we have 3 over 4. It's not on the unit circle. Okay, so if I draw it out now, it's got to go in quadrant 1 because it's positive. Okay, so I know that this side is 3, and I know this side is 4, and then this side is going to be root 7. Okay, so then inverse sine of 3 over 4 is just some angle, and then the cosine of that angle is going to be root 7 over 4. So adjacent over the hypotenuse. Okay, and then the last one, we got tangent of inverse cosine of negative 5 over 7. Okay, now the only place where inverse cosine is negative, all right, has to be in quadrant 2. Okay, so if I draw my triangle, I know that this is going to be negative 5, and I know this is going to be 7. Okay, so the difference between the two, what is that? That's, can't do math in my head. So 25 plus y squared equals 49. So 24, which we then know is perfect square. That is going to be 4. All right, so we know that this is 2 root 6. All right, that took longer than necessary, but that's okay. Okay, so again, this is you're going to turn this into tangent of this angle, all right? So inverse cosine of negative 5 over 7 becomes the angle, and then the tangent of that angle is going to be opposite over adjacent. So it's 2 root 6 over negative 5. All right, so that's pretty much how you're going to be doing inverse cosine, or I'm sorry, inverse trig functions. Again, as long as you guys pay attention to the area on the unit circle that you have to use, then it's pretty easy from there. Okay, so if you have any questions, let me know. Thanks.